Okay, so section 6.8 is about the remainder and factor theorems. So let's start this off with the remainder theorem, which says that if you want to take a polynomial and divide it by a binomial in the form of x minus a, and you just wanted to figure out what the remainder would be, you can quickly just plug in a into the polynomial and evaluate it, and that will be your remainder. So for example, if we're going to take this polynomial right here and divide it by x plus 3, we can figure out what the a is. And if it's x minus a, this is really x minus a negative 3. So a would be negative 3. We take that negative 3 and we plug it in for x into our polynomial and quickly do these calculations, and we end up getting 16. So that means that had we gone through and done the long division, we would have ended up with a remainder of 16. Okay, next thing. We're going to learn about synthetic division, because this is a really quick way to divide a polynomial by a binomial that's in the form of x minus a. So for example, here's our polynomial. We're going to divide it by x minus 2. Just like before, we need to figure out what a is. So in this case, a is 2. And in order to set up synthetic division, we're going to take that 2, whatever the a is, and we're going to put it off to the side with a little half box or corner box around it to separate it from the next set of numbers. And the next set of numbers come from the coefficients of all the terms of your polynomial. And if we write those out, remembering to put a placeholder of 0, because this polynomial skips from x to the 4th down to x squared, we need to have that x cubed term, but since it's not there, the coefficient would be 0. Also, you need to remember to take the sign. So all of these were positive, except for this one was a negative 2. Okay, so the next thing, we draw a line to help keep us track of the numbers. You don't have to do that if you don't want to, but to start off synthetic division, the very first thing we're going to do is take this 4 and bring it below the line. And then the next thing is we're going to take 4 and multiply it by a, which is 2, so we get 8. And we place it in the next column underneath the 0. And then we add these two together and place it below the line. And we just keep performing those operations of multiplication and addition. We multiply again, and we add, and then 36 times 2, 72, we add, we get 73. So you can see those quick calculations that you can do, especially when these numbers are pretty small. You can do all these calculations in your head fairly quickly. So what do we do with this string of numbers that we've created down below? Well, the first thing to make note of is this very last number is going to be the remainder when you divide. So we know that this is going to have a remainder of 73. The next thing that we need to know is that all 4 of these numbers are going to be the coefficients of the terms of our answer. So the leading term is going to have a coefficient of 4. And so we need to place the variable back into our polynomial here. And the exponent of the very first term is going to be 1 less than the degree that you started with. So our polynomial that we divided had a degree of 4. So our answer's polynomial will have a degree of 3. So this is going to be 4x cubed for the first term. And then for each of these coefficients, we just decrease the exponents by 1. So this is going to be an 8x squared, and then a 19x, and then a 36. And then the remainder, of course, we would write as 73 over x minus 2. So this is a really quick way to do your long division, but it only works when you're dividing by a binomial in the terms of x minus a. All right, let's move on to the factor theorem. So the factor theorem says that if x minus a is a factor of a polynomial, basically if you can factor your polynomial and one of the factors is x minus a, you'll know this because if you plug a into the polynomial, you should get a remainder of 0. Right? So think about that. If you were to divide your polynomial by a factor, it should divide in nicely and have no remainder. So the polynomial will end up being 0, which we saw from the remainder theorem that would indicate the remainder when you divided. Okay, so it all seems very logical, right? So if you want to figure out that if x minus 4 is a factor of this polynomial, there's actually two different ways you can do it. You can use the factor theorem, like I just set up here, and plug in 4, but these are kind of large numbers, but you can kind of tell almost right off the bat, since all of these are added together, this is not going to turn into 0. So if it's not 0, then it's not going to be a factor. If you couldn't tell right off the bat, you could use synthetic division if you wanted to, which is actually pretty quick once you set it up. You know, and at a certain point you realize that you're going to add these, you're going to get a number that has to multiply to 4. It's not going to be negative 20. It's actually going to be something quite large. So our remainder is 360, which once again, we already know is not 0, so it's not a factor. So I know that some problems will ask you, is this a factor? And if the answer is yes, then continue on and factor your polynomial completely. So in that case, if that's the kind of question you're asked, this is probably the best method to use, because if it does in fact turn out to have a 0 here, then you've already done the first step of factoring. So you kind of are taking care of two things at once. But it's up to you which method you would want to do to test. Okay, so next, what if they just give you a polynomial and they ask you to factor it completely? They don't even tell you a possible binomial factor. So where do you start? You have to use synthetic division since this has a degree of greater than 2. So where would you start? There's an infinite number of numbers that could be a, right? So we can actually limit our pool of numbers to choose from by looking at factors of your constant. Because if it's going to be able to be factored completely, a will be one of those factors of that constant. Okay, so that's a nice little trick. Now 18, I know, is a big number with lots of factors, and we have to include all the negatives, so plus or minus 1, plus or minus 2, and so on and so forth. So we do just start testing it, and the best way to test it is to use synthetic division because it is quite quick. Okay, so if we try 1, that obviously did not work. We can try negative 1, test that again. Nope, we didn't get 0 for a remainder. Let's try 2. That doesn't work. Keep going. Try negative 2. And that one did work. So sometimes it can take 4 or 5 different tries before you get the right one. Or you could go through all of these and it doesn't work. Like none of them work. And that means that your polynomial can't be factored. So just stick with it. Persevere. Don't give up. It might be a lot of work, but you know, it's not hard. It's just tedious. All right, so if this is a remainder of 0, that means that this is the a for the binomial factor. So that means x plus 2 is going to be a factor. Remember to change the sign, right? But it also means that we have, when we put these back as the coefficients, we end up having x squared minus 9 as well as a factor. But this is the difference of squares, so it said to factor completely. We can factor that even further to be x minus 3 and x plus 3. And then don't forget the x plus 2 that we got from this. Looking at this completely factored form here, this tells us that if we had plugged in 3 for a or negative 3 for a, those also would given us a 0 for a remainder. So any one of those 3a values there would have worked. But negative 2 was the first one that we encountered, so that's the one we went with. All right, so that's it, folks, with the factor and remainder theorems. Have fun.